Hello everyone! Today we're going to go over Target 1A, just a quick overview of what we learned this whole time. Okay, the first thing that we talked about in Target 1A is following standard form. Now the way we did that is by organizing our polynomial from largest exponent to smallest. So let's do that. The largest exponent I see here is an x to the 6th. So that's the first thing that I write down. We have to keep the symbol with it. If it was a plus, we don't write a plus usually to mean positive, so I'll just leave that minus out front to remind ourselves it's actually a negative. Okay, the next largest exponent is a 2, so 2x squared. Then we have x to the 1st, so just a regular x. And lastly, we have our constant. And that's going to be the term without any variables. And that always goes last. Let's do the same thing with this polynomial. That's a small one. Good. The largest exponent I see is, once again, it's a negative. So we have an x to the 3rd. Make sure to bring that negative with us. The next largest exponent I see is x to the 1st. So minus 6x. And then lastly, we have our constant. 1/6 doesn't have a sign in front of it, but that means it's positive. So I'm going to write a plus and then 1/6. After we were able to rearrange these polynomials, we gave ourselves some words to describe them. So let's look at that. Right, the first thing we did is we rearranged our polynomials. So let's do that first. Let's make sure to write them in standard form. Try making this a hobby. Hobby? I meant to say habit. I mean, if you really want to make organizing polynomials a hobby, you can. But I'm not sure even a math nerd like me would do that. That's a little too much. Okay, so I reorganized them in standard form. There we are. Let's talk vocabulary. The first thing we have here is a leading coefficient. That is going to be the number that is attached to the variable with the largest exponent. So in this case, it's going to be 4. The degree of our polynomial is going to be the largest exponent we have, which is a 3. So it's a 3rd degree polynomial. Now, at this point, I'm just going to go ahead and skip to the name portion. Anything with the power of 3 is called a cubic. Okay. Lastly, let's see our number of terms. Now, our number of terms means we're looking at how many things do we have in our polynomial that's separated by plus signs and minus signs. So here I have 1 term, 2 terms, 3 terms. And since I have this red thing open, let's just do the number of terms for this one. So we have term 1, term 2, term 3. So it doesn't matter if there's minuses or pluses around them. I'm not asking you if these are positive or negative terms. I'm just asking you how many are there. Okay. Let's do leading coefficient. Now this one's funky. I don't really see a number attached to the variable with the largest exponent. Whoops. Let's undo that. Crazy highlighting. There we go. I really just have this negative. So what the heck is that negative? That negative is our invisible -1. The degree is 5, which means I could name it right away. 5th degree polynomial is known as quintic. We're going as high as 5th power. We're not going to name anything after the power of 5. We'll just call it 6th power polynomial, 7th power. Well, we won't go crazy with all the names. Okay. Once we were able to name all of our parts of the polynomial, we can start talking about it a little more. So this is what we did. We started talking about Just making sure I didn't leave myself any work down here. Nope. Okay. We started talking about the relative maximums, minimums, extremums, and zeros. So a little bit more vocabulary, but applying it now to a graph. Okay. So when we talked about relative maximums, what we were talking about are high points. Not the highest, but high points that are in our function. Well, let's see. This is a visual thing. These relative maximums have to exist on the top of a hill, so on the top of a U-shape. So let's find those upside down U-shapes on the top of the hill of the upside down U-shape. We have A, we have D, and we have letter F. Sweet. We also have relative minimums. This is the right side up U-shape. And our minimums are going to exist on the bottom of that U-shape. It's the lowest point, or lower point. Not the lowest, but one of the lower ones. Here I see letter B and letter E. All right, relative extremes. Relative extremes actually combines relative maximums and minimums. So relative extremes are all the maximums and minimums we already highlighted. So if I asked you to just tell me relative extremes, you would give me 5 points. A, B, D, E, and F. Next, I'd like us to label the y-intercept. And I'm just going to use blue to circle it. The y-intercept would be right here, where we cross the y-axis. And lastly, which points are zeros? Zeros are points that cross the x-axis. So we have one right here on letter A, one right there on letter C, one right here on letter E, and yet another one right here on letter G. So I did that in purple. So y-intercept is where we cross the y-axis, zeros are where we cross the x-axis. Sweet. There are still more features, not just talking about the equations, not just looking at the tops and bottoms of those hills, not just talking about the x and y intercepts. Now we have to really look at the arms and what they tell us. And by arms, I mean the arrows that are pointing upwards, downwards, on the left and right side of our polynomials. Polynomial features talk about even and odd polynomials. I'm going to add in the word degree, even degree polynomials, and odd degree polynomials. Okay, so what does that mean? That means like x squared, x to the fourth, x to the sixth. Those are all even exponents, so they're even degree polynomials. Let me show you what they look like. We have two types. We actually have a positive polynomial that's even. It has both arms facing upwards. We also have even polynomials that are negative. And I'm just making them up. All right, don't ask me for that equation. I don't know. But I do know it's negative because both arms are pointed downwards. Similarly for odd degree polynomials, positive odd degree polynomials, regardless of what they look like and how good of an artist Ms. Guman is, we have left arm down, right arm up. Opposite for the negative. We have left arm up, right arm down. Now in general, the easiest way I've found to remembering which is even, which is odd when we look at the picture, odd polynomials have opposite arms. They're facing in opposite directions. Let's use some of the vocabulary that we've learned over the course of these few little sections in Target 1A to describe this polynomial. First of all, I ask you, is this an even or an odd degree? Well, see how these arms are in opposite directions? Right there? That means it's an odd polynomial. Opposite arms, odd polynomial. The leading coefficient, is it positive or negative? Well, let's see. Left arm up, right arm down. That means negative. Real zeros. Let's find out. Zeros are where we cross the x-axis. Let's count how many we have. 1, 2, 3, 4. 4 real zeros. And then I'm also asking for extreme values. That means the topmost or the top of the hill or bottom of the U shape. So let's see, we have one here, we have one there. Actually, this 0 is also a minimum because it's a U shape. And then we have one up here. So 1, 2, 3, 4 relative extremes. I counted these two minimums and the two maximums. Let's do this one more time. Now I'm asking you once again if the degree is even or odd. Take a look at the arms. See how they're both pointing upwards? This means we have an even polynomial. This one's a little easier to know whether it's positive or negative because you just look at the direction of the arms. They're both pointed up, which means positive. Let's label some zeros. Zeros are our x-intercepts, or where we cross or touch the x-axis. There's 3 zeros. And I'm asking you about relative minimums. These are the bottom of the U shape. So there are 2 relative minimums. There we go. Okay, but we got even more detailed about this. We talked about the direction of the arms, which one's up, which one's down. We talked about y-intercepts. We talked about x-intercepts. We talked about maximums and minimums. Now let's talk about those arrows, the end behavior, the arms of our polynomials. Okay, so we need to look at 2 things when we talk about end behavior. We need to take a look at the behavior of the x's and the behavior of our y's. Let's do this. Okay, so first thing we have is as x approaches infinity. Well, where does x approach infinity? Well, approaches it on the right-hand side of the graph. Because if we keep going to the right, as you can tell by the numbers listed, x's keep getting larger. So what's happening to our y's? Well, let's see. For our y's, I'm going to look at the up and down. So let's see, on the right side of my graph, my arm is going upwards, so y is also approaching positive infinity. I'm really bad at drawing infinity, so you're going to get this as my infinity symbols. Apologies. Okay. Next, I'm being asked, well, what happens as x approaches negative infinity? Well, x approaches negative infinity on the left-hand side of the graph. As you can see, the negative numbers just keep getting smaller. So let's take a look at the left-hand arm. The arm is going downwards, so y is approaching negative infinity. Let's do the same thing on this graph. First, we have x approaching positive infinity, which is on the right-hand side. So let's take a look at the right arm. The right arm is pointed downwards, so y is approaching negative infinity. Next, I'd like to know, well, what happens as x approaches negative infinity? So that's the left-hand side of the graph. The numbers are getting smaller. So let's look at the left arm of our graph. This left arm is also pointed downwards. Y is approaching negative infinity. Okay. Now, we talked about the directions of the arms, what they're approaching. We're going to put it all together and also talk about the last feature of our polynomials, which are their domains and ranges. Okay, So just as a reminder, excuse me, and a little burp there, our domain talks about our x's and our range talks about our y's. Okay, so let's keep that in mind as I go over this. All right, first let's talk about domain. When I'm looking at domain, I'm looking from left to right. Well, my leftmost point. Well, do I have a leftmost point? No. If you take a look here, on the left-hand side of my graph, I just have an arrow. It just keeps going left. So that means on the x's, I just keep getting smaller and smaller because I keep going to the left and to the left. I'm approaching negative infinity. Fine, let's take a look at the right-hand side of my graph. I'm looking at this arm and it's also pointed upwards, which is great. It's going to the right infinitely. Infinities get parentheses symbols. Okay, next, let's talk about the range. Range talks about our y's. We go from the bottom to the top. Okay, well, what's our bottommost y? Our bottommost y is a -6. What about our topmost y? Well, if you take a look at these arms, those arms are going upwards for forever. They have arrows. They don't want to stop. So the largest y is actually infinity. There is no largest y. Infinities get parentheses no matter what. Now what about our -6? Does our -6 exist on our graph? Yeah, there's a point right there. I believe this is a -2. It'd be -2, 6. Since it exists on our graph, I'm putting a bracket. Now let's take a look at bracket versus parenthesis on this one as well. Okay, so we have domain. Domain, once again, these are our x's. We're going from left to right. Okay, on the left-hand side, the smallest x I have is a -3. On the right-hand side, the largest x I have is a +3. On the left, I have a filled-in dot. That means it exists. The -3 gets a bracket. On the right-hand side, you notice I have a dot, but it's drawn kind of like an O. It's an open circle. Open circles get parentheses. Let's use our range. Okay, range. We're going from the bottom to the top. So bottom, top. Okay, so the smallest y I see there is -4. The largest y is +2. -4 is has a closed point, so it's a bracket. The 2 has an open circle, so it gets a parenthesis. All right, one more and we are done with target A. Let's do domain. Domain. Once again, we're going from left to right. Okay, well, on the left-hand side, it looks like I'm going down forever, which means I'm going to negative infinity for forever, for the x's. Because not only am I going down, I'm also on the left-hand side. So I'm just going to keep getting smaller y's and smaller x's. On the right, I also have a down arrow. That's fine. As long as that arrow exists on the right-hand side, that means our x's exist. They're getting infinitely larger because it's on the right. And lastly, let's talk range. Range, once again, we go from bottom to top. Okay, on the bottom, you see how we have arrows pointing downwards? That means that the y's are getting smaller for forever. Well, what's the largest y you see? Well, the largest y I see is right here, and that is 9. Infinities always get parentheses. This 9 exists on our graph. There's this point right here on this maximum, so it gets a bracket. Okay, so a quick 20-minute rundown of Target 1A. This is what we learned. This is how it's all related to each other. Please ask myself or your teachers any questions you have when working on this stuff, and we'll be happy to help you. Have a wonderful rest of whatever day it is for you. Bye!